All right. Hello. In this video, we're going to be talking about proportional sides. We're going to do that by talking about first divided sides. So what divided sides are, if a line is parallel to one side of the triangle, and if it intersects the other two sides, so I had to replace that word intersect, that was a typo, should have said intersects, then it divides the other two sides proportionally. What that means is that if you've got these two lines, so let's say if DE is parallel to AB, then what we can say is that the side DC over DA is going to be proportional to CE over EB. Now the converse of this is also true. So if a line divides two sides proportionally, then it must be parallel. In other words, we can say that if DC over DA is equal to CE over EB, then we can conclude that DE is parallel to AB. In other words, if you know that the sides are proportional, then what you can do is say that the two lines here are parallel. All right, let's talk about some other proportions that'll work. So besides the one that I've shared with you, there's some other proportions that'll work as well. Now, obviously, AB is going to have to be equal to XY, so A matches with X, B matches with Y. But AC, so if you take shorter and longer, that's going to be proportional to shorter and longer, so X over Z. For BC, same idea. So if you've got B and C, that would be proportional to Y and Z. All right. So if you've got A is proportional to X, so going across, then B has to be proportional to Y. Next, if C is proportional to Z, so if you've got the two larger sides that are proportional, then you can say two different things. So notice that we've got it written twice. You can first say that A is proportional to X. You can next say that B is proportional to Y. So lots of different proportions that you can use when you've got this scenario where you've got the triangle with a parallel side and a parallel line contained within it. With two sides, any combination will work as long as you're consistent with both of the ratios. But with the third pair of sides, the two that are actually parallel, this is not going to work. Instead, you're going to have to use a definition of similar triangles. In other words, what we're saying here is that if you have A proportional to B, what will not work is you cannot say that P is proportional to M. So you can't use the actual sides that are parallel themselves. So let's use this information to solve some problems. In our first triangle that we've got, notice that we've already got our parallel sides. We can say that if 12 is proportional to 14, that 15 is proportional to X. And then solving that, we would take 12 multiplied by X is 12X, 14 multiplied by 15 is 210. And then to get X by itself, divide each side by 12, you're going to come up with X being equal to 17.5. All right, let's try another one. So we can say, because our two lines are parallel, that X being proportional to 18 is going to be the same as 56 being proportional to 21. And when we cross multiply, we're going to get 21x is equal to, take 18 multiplied by 56, is 1008. And then to get x by itself, just divide each side by 21, and you'll come up with x being equal to 48. All right, so you notice pretty easy stuff, really. Let's take a look at a few more. So, on our next problem, we've got 24, 14, 18, and x. Now, here's kind of the thing about these two triangles. We're not going to actually be able to, well, let's see what we can say about these two triangles. Because we cannot just go straight to saying x is proportional to 14 and that 18 is proportional to 24. Remember that that was one of the things we were not allowed to do was with our two parallel sides. However, what we can say is because these two lines are parallel, that these two angles are proportional. We can also say that these two corresponding angles are proportional, and obviously this angle is proportional to itself. So these two triangles are similar by angle-angle similarity. And so even though we cannot say it directly with the ratio that we normally would, we are going to be able to say it because these two are similar. All right, so let's take a look at how this is going to work here. We're going to say that x is proportional to 14 and that 18 is proportional to 24. So now let's go ahead and simplify a little bit. We'll take 24 multiplied by x is 24x. And then we'll take 18 multiplied by 14, which is going to be 252. Which then just divide each side by 24. And we're going to be able to say that x is equal to 10.5. All right. So on this next problem, notice that it's set up a little bit differently because we're not told what this side length is right here. But it'd be pretty easy to find that side. If we know that that side plus 45 has to add up to be 55, then just take 55 minus 45 to figure out that the length of that side that was missing was 10. And now we can set this up and say that 10 is proportional to 45 in the same way that x is proportional to 36. All right, so simplifying a little bit, we're going to take 45 multiplied by x is 45x. 10 multiplied by 36 is 360. And then to get x by itself, divide each side by 45, and we're going to come up with x being equal to 8. Notice that on the next triangle, we can actually do something similar. You've got that the entire length is 12, the smaller length is 8. Take 12 minus 8, and that'll tell you that this shorter length here is 4. So now we can set up a proportion using those. We can say that 4 is proportional to 8, and that 6 is proportional to x plus 2. So let's go ahead and multiply. 4 multiplied by, in parentheses, x plus 2 is equal to 8 multiplied by 6, which is 48. Now you can work this one of two ways. If you want to go ahead and distribute the 4 to the x and the 2, you can. If you'd rather just divide each side by 4, though, you can do that as well. So that would be that x plus 2 is equal to 48 divided by 4, which is 12. The nice part about working it this way is that then you can just subtract 2 from each side, and then you're done. X is equal to 10. All right, let's take a look at one last problem, kind of looking at how these work. So on this last problem, we've got the two sides already. We can say that 21 is proportional to 6 in the same way that 3x plus 1 is proportional to x minus 1. All right, so let's do our cross multiplication. So 21 multiplied by x minus 1 is equal to 6 multiplied by 3x plus 1. All right, so now let's go ahead and distribute. So we're going to have 21x minus 21 is equal to 18x plus 6. All right, so let's get all of our variables to the same sides. Subtract 18x. We get that 3x minus 21 equals 6. Add over the 21. We get that 3x is equal to 27. And then finally divide each side by 3. And we get that x is equal to 9. All right. In these next two problems, we're going to decide going the other direction if our two lines are parallel. So notice we're not told they're parallel. We're going to have to figure that out for ourselves. What that means is we want to check to see, is 11 over 15.4 the same as 10 over 14? Which 11 over 15.4 as a decimal is 0.71. And 10 over 14 as a decimal is the exact same, 0.71. So yes, we can in fact say that MN is parallel to JL. In other words, this line is parallel to this line. All right, let's try the same thing on this last problem. So we're going to check, is 15 over 4 the same as 18 over 5? And 15 over 4 is 3.75. 18 over 5 is 3.6. So these are not equal to each other. So no, we are not going to be able to say that they are parallel. All right. The last concept that we are going to talk about is the idea of what are called parallel proportions. And then we will actually, let me step back a second. And we do still have an angle bisector that we'll talk about. So two more concepts left and then we'll be done. All right, so parallel proportion says that if three parallel lines intersect two transversals, then they divide the transversal proportionally. Another typo there, then they. What that means, notice that you've got three lines which are parallel. X is parallel to Y, is parallel to Z. And you've got two transversals, in other words, two lines that cut through them, W and P. What that means is that A over C is proportional to B over D. All right, so let's kind of talk about kind of how this is going to work. So on this first one, notice again, we've got the same setup. What we can say then is that 12 over 30 is proportional to 14 over X. Doing our cross multiplying, we'll come up with 12X being equal to 30 multiplied by 14, which is 420. And then to get X, divide each side by 12. You'll come up with X being equal to 15. On the next one, same idea. We can say that 2X plus 2 is proportional to 21, and that X plus 3 is proportional to 12. Again, you can cross multiply. Be careful to leave everything in parentheses until you distribute. And now we can go ahead and do that distributing. So 12 multiplied by 2X is 24X. 12 multiplied by 2 is 24. And then 21 multiplied by X is 21X. 21 multiplied by 3 is 63. So now let's get all of our variables to the same side. We'll subtract 21X from each side. So we've got 3X plus 24 is equal to 63. Now let's move over the 24. So we're going to go ahead and subtract 24 from each side. We'll have that 3X is equal to 39. And then to get X by itself, just divide each side by 3. And you'll come up with X is equal to 13. For this last one, again, anytime you've got the full length side of 32 and you want the shorter side here, just take 32 minus 18. We'll tell you that that shorter side length is 14. And then you can set up your proportion like normal. So 27 is proportional to X in the same way that 18 is proportional to 14. So now take X multiplied by 18 and 27 multiplied by 14, which is 378. So now to get X by itself, just divide each side by 18, and you'll come up with X being equal to 21. All right, now we actually have our final concept. So the angle bisector proportion. So if we have a ray which bisects an angle of a triangle, in other words, what it means by bisects is that this angle and this angle are equal to each other. Then it's going to divide the opposite side into two segments whose length are proportional to the length of the other two sides of the triangle. What we mean by this is that A over B, so this side over this side, is proportional to taking C over D. So let's take a look at some examples of this. So we've got our angle bisector. What that means is that 2 over x is proportional to 6 over 9. Now, in order to solve, again, you're going to cross multiply. So 6x is going to be equal to 18. To get x by itself, divide by 6 on each side, and you'll come up with x being equal to 3. On this next triangle, we've got the same idea. We've got our angle bisector, which means that 3 over 4 is going to be proportional to 7 over x. Go ahead and cross multiply then. So 3 multiplied by x is 3x. 4 multiplied by 7 is 28. And then to get x by itself, divide each side by 3. And you're going to end up with a decimal. X is equal to 9.3 repeating. All right, 2 last problems to look at, and these are a little bit different, so make sure you stick around for these last 2. Because we don't know exactly what this length is, because we don't know what x is. So what we're going to do is think about what we would have done. Like if x was 5, then we would have taken 40 minus 5. Since we don't know what that side length is, we don't know that it's 5, instead of taking 40 minus 5, we're just going to take 40 minus x. And then we'll set up our proportion using that. So we can say that x is proportional to 40 minus x in the same way that 24 is proportional to 36. And then we can go ahead and do our cross multiplication. So we can say that 24 multiplied by, in parentheses, 40 minus x must be equal to 36 over x, or 36 multiplied by x. Go ahead and get that fixed. All right, so now we'll go ahead and distribute. 24 multiplied by 40 is 960. 24 multiplied by x is a minus 24x is equal to 36x. So now let's move all of our x variables to the same side. We'll add 24x to each side. We're going to have that 960 is equal to 60x. And then to get x by itself, just divide each side by 60, and we'll get that x is equal to 16. In our last problem, we're going to do something very similar. So again, just like we did before, where we took 40 minus x, this time we're taking our full length of our side, which was 20 minus x. So we know that 20 minus x over x is going to be proportional to 11 over 14. So then we'll cross multiply. We'll get 11x is equal to 14 multiplied by, in parentheses, 20 minus x. Then we can go ahead and distribute. 14 multiplied by 20 is going to be 280 minus 14x. And then add 14x to each side. We're going to have that 25x is equal to 280. And then to get x by itself, just divide each side by 25. And we're going to get that x is equal to 11.2. All right, that is it for this video notes, and that is it for Unit 1. Until next time, have a great day.